Imagine a world where you could walk from Antarctica to North America without crossing an ocean. The Atlantic and Pacific didn't exist, just one vast global ocean, Pangaea, surrounding a single supercontinent, hundreds of millions of years ago. All the continents we know, Africa, Asia, the Americas, Australia, Antarctica, were fused together as Pangaea. The interior of this land was a harsh, arid desert, far from the ocean's moisture. The coastlines faced the relentless waves of Pangaea. We're so used to our divided continents that it's hard to picture them as one. But the evidence is everywhere, in rocks, fossils, and the shapes of our coastlines. This is the story of Pangaea, a time when Earth was truly one. Imagine the journeys possible. A creature could wander from what's now Brazil to West Africa, with no ocean in the way. Life spread freely, shaping evolution in ways impossible today. The world was both vast and intimately connected. Exploring this ancient past is like detective work, piecing together clues from mountains, soils, and fossils. These clues reveal a time when all land was united. Understanding Pangaea isn't just about the past. It helps us grasp our present and glimpse Earth's future. The story begins with a simple idea: all lands were once one. Pangaea, meaning all Earth in Greek, was the supercontinent that dominated our planet for over 150 million years. It formed around 335 million years ago and began breaking apart about 175 million years ago. Pangaea stretched from pole to pole, curving around the warm Tethys Sea. The rest of the planet was covered by Pangaea, the global ocean. The center of Pangaea was a vast, dry desert, while the coasts experienced powerful monsoons and torrential rains. This created a world of extremes, a parched heart, and lush, stormy edges. Towering mountains, some rivaling today's Himalayas, rose where continents collided. With few barriers, animals could migrate across the entire landmass. Fossils of the same species are found on continents now separated by oceans, a key clue to Pangaea's existence. The rocks and fossils from this era prove that life once moved freely across a unified world. Pangaea's geography shaped evolution in ways we're only beginning to understand. Its legacy is written in the stones beneath our feet. Life on Pangaea was both alien and familiar. Before dinosaurs ruled, sail-backed reptiles like Dimetrodon roamed the land, using their sails to regulate body temperature. Fossils of creatures like Lystrosaurus are found in South Africa, India, and Antarctica, proof they walked across a connected world. The landscape was dominated by giant ferns, mosses, and primitive conifers. No flowers or grasses yet. Lush forests thrived near coasts and rivers, while the interior was sparse and dry. The end of Pangaea's unity brought catastrophe. The Permian-Triassic extinction, or the Great Dying, wiped out most life on Earth. Massive volcanic eruptions triggered this event, clearing the way for new life to evolve. From the ashes, dinosaurs would rise as Pangaea began to break apart. The fossil record tells the story of a world both connected and vulnerable to dramatic change. Pangaea's breakup set the stage for the world we know today. Its legacy lives on in every continent and every living thing. For centuries, mapmakers noticed that continents like South America and Africa fit together like puzzle pieces. At first, this was dismissed as coincidence. How could continents move? But geologists found matching rock layers and mountain ranges split by oceans, like the Appalachians and Scottish Highlands. Evidence of ancient glaciers in now tropical regions and coal in Antarctica deepened the mystery. The only explanation: continents had shifted positions over time. Fossils, rocks, and climate clues all pointed to a lost world where the continents were once joined. These hints whispered of a dynamic Earth, not a static one. But science needed more than scattered clues. It needed a unifying theory. The idea of moving continents was radical, and most experts rejected it. It would take a bold thinker to connect the dots and challenge the status quo. That thinker was about to step forward. Alfred Wegener, a German meteorologist, pieced together the evidence for continental drift in 1912. He argued that all continents were once joined as Pangaea, then slowly drifted apart. Fossils, rocks, and climate patterns supported his theory, but Wegener couldn't explain how continents moved, so most scientists dismissed his ideas. He faced ridicule and died before his theory was accepted. Decades later, new discoveries about the ocean floor revealed the missing mechanism: plate tectonics. Wegener's vision was finally vindicated. changing our understanding of Earth forever. His story is a testament to the power of curiosity and perseverance. Pangaea's breakup was a slow, dramatic process driven by plate tectonics. Earth's outer shell is made of giant plates floating on a molten layer below. Heat from the core creates currents that move these plates, carrying continents with them. Around 175 million years ago, Pangaea began to split. Huge rifts formed, magma surged up, and new ocean crust pushed the land apart. The first split created two supercontinents, Laurasia in the north, Gondwana in the south. The Atlantic Ocean began as a narrow rift, slowly widening over millions of years. Volcanic activity and earthquakes marked the birth of new oceans and coastlines. Gondwana fractured further. Africa and South America drifted apart. India sped north. Australia and Antarctica separated. Each split reshaped the planet, creating the continents we know today. The Mid-Atlantic Ridge is a scar from this ancient breakup, still pushing continents apart. The age of supercontinents ended, replaced by a world of shifting plates. Plate tectonics continues to shape our world, moving continents even now. The story of Pangaea's breakup is written in the rocks beneath our feet. The breakup of Pangaea set the continents on a slow, ongoing journey. Oceans like the Atlantic and Indian grew as continents drifted apart, at the pace of growing fingernails. India's rapid northward trek ended in a colossal collision with Asia, creating the Himalayas, which still rise today. Earthquakes and volcanoes are surface signs of these deep, powerful movements. GPS now tracks continents shifting in real time. North America moving away from Europe, Australia drifting north, Africa splitting along the East African Rift. The world map is just a snapshot. Continents have always been on the move. The dance that began with Pangaea's breakup continues, reshaping our planet. Every mountain, ocean and valley is a product of this restless motion. The continents are passengers on a moving conveyor belt, never truly still. Our planet's face is always changing, shaped by the slow power of plate tectonics. The story of Pangaea is still unfolding beneath our feet. If continents are still moving, where are they headed? Geologists predict that, far in the future, the continents will reunite in a new supercontinent, Pangaea Ultima. The Atlantic may eventually close, bringing the Americas back to collide with Europe and Africa. Australia and Antarctica could join Asia, forming a single massive landmass. The climate would be extreme, with vast deserts and towering new mountains. Life would adapt to this new world, just as it did before. Other models suggest different outcomes, like the formation of Amasia if the Pacific closes instead. The details are uncertain, but the principle is clear. Earth's continents are destined to come together again. The forces that broke Pangaea apart will one day reunite its scattered pieces. Our planet is always in motion, always remaking itself. Pangaea's story is more than ancient history. It's a lesson in Earth's restless nature. The continents and oceans we know are temporary, shaped by forces that never stop. Scientific curiosity turns scattered clues into a revolutionary theory, changing how we see our world. The courage of thinkers like Wegener reminds us that challenging old ideas can lead to great discoveries. The forces that shaped Pangaea are still at work, building mountains, causing earthquakes, and forging new lands. Understanding this deep history gives us perspective on our place in the world. Nothing on Earth is permanent. Landscapes are fleeting chapters in a much longer story. We live in just one moment of an epic planetary journey. By looking back at Pangaea, we appreciate the creative, ever-changing planet we call home. The story of Pangaea is the story of Earth itself, dynamic, powerful, and always moving.